Let's try to join again. Let's see if you can. Okay, I've seen one person has rejoined. Network is not always a friend, but let's see what we can do as regards this. Please rejoin. Let's see what we can do. Yeah, let's wait a bit and see. Okay, I've seen 3 people joined. Just hope more will join. 4. I've seen 4. So I think we can start. We don't need to waste for others. So, like I said, I want to share a document. I hope you guys have writing materials. I hope you have writing materials because this is physics and we need to do some writing. And I want to make reference to the textbook we're using. The textbook we're using, so I will try to see if I can share it here. So if you are able to see it, you let me know. Let me know. Okay. Can you see the textbook? Okay, you can see it. Good. Okay. So just like I'm explaining, when you look at this, I told you that vectors can be added, can be subtracted, and you can only add vectors. You can only add vectors when they are moving in the same direction. So look at this. Look at where my arrow is going. These are 2 vectors. P is 50 Newton and the other P is 40 Newton. The arrow is showing that they are moving in the same direction. So what is here is the resultant. What is the resultant? Is the total the total vector, the total or nets or resultants, they means the same thing. So for you to have this R, you simply add 50 plus 40. And that is the reason why you are getting R equal to 90. You get? And that question says if two vectors P and Q of magnitude 50 Newton and 40 Newton respectively out on a body in the same direction, that is number one, in the opposite direction, obtain the resultant of this. So in this case, what you need to do is to simply for the I, the same direction you add. Then for the uh, in the opposite direction, R will be P minus Q. Please, this is a typographical error. P is so that is the resultant. So if they are moving in the opposite direction, you subtract. If they are moving in the same direction, you simply add. So vectors is what we call commutativity. Addition and multiplication are commutative. I hope you guys are hearing me. Can you hear me? Can you hear me? If you can hear me, so that you can move on. Please let me know if you are hearing me. And you are, if you are also seeing the documents. Okay, okay. Are you also seeing the documents? Are you also seeing the document? Please let me know. You can't see the document on the screen. I mean your textbook. I have shared. I have shared the textbook. Yes. But it's showing on my screen. I mean the textbook. But it's being displayed on the screen here. The textbook is being displayed. Can you see the cursor, the arrow? Can you see the arrow moving? Okay. I don't know why it's not showing, but let's continue. But I just wish you have a copy of your textbook there. Does anybody have a copy of the textbook there? Okay. So if you have the copy of the textbook, look at page 21. That is where I'm discussing. Page 21. Page 21. If you can see it, that diagram, example 2.1, where they say if two forces P and Q of magnitude 50 Newton and 40 Newton respectively act on a body, one in the same direction, two in the opposite direction, obtain the resultant force in each case. Like I said, the resultant is a total force. Sometimes they say net effective. Resultant, total, net effective means the same thing. So if the forces are moving in the same direction, you simply add. And if they are moving in the opposite direction, you simply subtract. So now another question is, if these two vectors are inclined at an angle, what do you do? How do you navigate from there? Now look at page 22. Page 22, you can see that diagram, figure 2.3. Can you see it? Can you see page 22, figure 2.3? Can you see that page 22, figure 2.3? If you can see that diagram, I want to explain something. These two vectors, P and Q, are acting at an angle, theta. These two vectors are acting at an angle, theta. But can you see the arrow? Can you see the arrow? Where the arrow is pointing? So even if you can't see, no problem. If you have your textbook there, we can move on. you can move on. If you can see this arrow, this is where the diagram is. So if you have your textbook, let's look at that. P is on the vertical axis, Q is on the horizontal axis. And you can see that the two lines are parallel. So for you to, and that angle between the two vectors is 90 degrees. And we know that we can only use Pythagoras theorem when the angle inclined is 90 degrees, or when the two vectors are perpendicular to each other. That's another term we can use, perpendicular or 90 degrees. So in this case, you can see that R, that is the resultant. And from there, Pythagoras theorem, R will be the square root of P squared plus Q squared. That is the Pythagoras theorem. And then for you to find that angle, sometimes you'll be given the two vectors inclined at or perpendicular to each other, then ask to find the angle. In that case, you know that we have P is the opposite side, while Q is the adjacent. Is that right? So from SOHCAHTOA, if you have tan means adjacent, that is, you have TOA means TOA, opposite over adjacent, that is P all over Q equal to tan theta. That is what you see, and that is why you have theta is equal to tan inverse of P over Q. So the next example there, you say a car traveled due east. You know, we have the four cardinal points: north, south, east, west. North, south, east, west. East by the right, west is by the left. So when they say a car traveled due east, it means it's going towards the right at 12 meters per second and later traveled 5 meters per second in the direction of the north. You can see east, north. So, and the question is, what is the velocity of the car? That is the resultant. And since the angle is is 90 degrees between the two vectors, we can also appeal to Pythagoras theorem. So you can use Pythagoras theorem only when the vectors are perpendicular to each other. Please, if there's any question, you can ask as we are going. If there is any question, you can ask, please. So, then we also have the parallelogram rule. That is, if the angle between the two vectors is not perpendicular, we can use the Pythagoras rule. So if you look at that diagram 2.4, that is where the parallelogram law is applied. In this case, the R, which is stand for the resultant, equal to P squared plus Q squared plus 2PQ cos theta. So looking at that, you can calculate the resultant, and sometimes you'll be asked to calculate the angle. In that case, sine rule will be applied. Sine rule. And when do you use sine rule? That's a big question. When you have a triangle, two sides are given, three sides. For you to use sine rule, three sides of the angle will be given with two angles, and you are asked to calculate the remaining angle. That is the only time you can use a sine rule. So if the initial angle is given, then you have to calculate the resultant. You will then be required to use to calculate the other angles. So if these conditions are met, you can apply the sine rule. So if you look at example 2.3, that is a typical case of a parallelogram law. So how do you now resolve two or more vectors? Resolution of vectors. Please, I want you to pay attention to this. In this type of your examination, questions that will be asked will not be too complicated. You just need your common sense to to solve them. Resolution of vectors. If you look at page 24, if you have your textbook, if you look at page 24, can you see it? Can you see page 24? Okay. You can see page 24. Look at that diagram where you have Vy, Vx, and then V. That happens. So it means that you can resolve this on both x-axis and on the y-axis. Where you have Vx is the y-axis, the x-axis. Where you have Vy is the y-axis. So you can resolve this vector on both x-axis and the y-axis. Resolving on the x-axis always have cos theta. Resolving on the y-axis always have sin theta. I've explained this several, but I will still explain now. I will still explain now. Now, on the x-axis, you have Vx and V. So if you produce that right angle triangle, what you have is the adjacent and the hypotenuse. And once you have adjacent and hypotenuse, you have cosine. And that's the reason why if you resolve on the x-axis, you normally have cos theta. If you resolve on the y-axis, you have sine. If you produce that right angle triangle, you have hypotenuse and the what? The opposites. SOHCAHTOA, opposite over hypotenuse. And that is why you have the sine. So if you look at that example 2.4, we said that Vx is equal to V cos theta. That is being resolved on the x-axis, which is equal to 3 times cos 30, which will give you 3 root 3 over 2 meters. Then on the y-axis, you have Vy equal to V sine theta equal to 3 times sine 30 degree, which is equal to 3 over 2 meters. So what if these vectors will have um, more than two vectors? Like if you see page 25, please, if you can see page 25, let me know. Okay. That diagram seems to be very complex. You have F1, F2, F3, F4. You have four forces here. You have four forces. So if you look at the how we solve, you have to resolve both on the x-axis and on the y-axis. F of x, that is resolving on the x-axis. F of y, you are resolving on the y-axis. So f of x is when the other left-hand side, x is minus. Then from the origin down, you have y to be minus. So if you draw the four cardinal points, you have positive y, positive x, minus y. So that's the reason why on that F2 is on the negative side. So you now have minus F2 cos theta 2 plus, when you look at F3, if you resolve it on the x-axis, it's also on the minus side. That's the reason you have minus F3 cos theta 3 plus F2. Once you resolve, this one is on the positive side. Then you have F4 cos theta 4. Please, if you have any question, you'll be asking as we are moving along. Please, if you have, ask question if any. Ask. You ask your question if any. So that is on the f of x. That is a horizontal. Then f of y. I explain why if you are resolving on the y-axis, you have a sine. So we are now going to resolve all the forces F1, F2, F3, F4. Looking at F1, if you resolve it, it's on the positive. Looking at F2, if you resolve it, it's on the positive y. Looking at F3, if you resolve it, it's on the negative y. The same thing with F4, if you resolve it, it's on the negative uh, y. So this becomes f of y equal to f1 sine theta 1 plus f2 sine theta 2 plus minus, because I've explained that f f3 is on the negative y. That's the reason why you have minus f3 sine theta 3 plus, the same way, f4, if you resolve, it will have minus f4 sine theta 4. So for you to get the resultant, for you to have the resultant, you have f to be equal to square root of f of x plus square root of f of uh, y square. Remember that f is the total resultant. And remember we have two components of f, the f of x and the what? F of y. And remember in this case, we have resolved them into x and y, and the angle is perpendicular. So we can apply Pythagoras theorem. We can apply Pythagoras theorem. So if you look at this, you solve that problem using the same approach. If you look at example 2.5, if you look at example 2.5, this diagram somebody is asking is current vector or scalar? I can't get that question right. I don't really understand what you mean by that. If you can explain more, we'll be able to. So if you look at this, if you look at this example, that diagram has a problem. Can you see example 2.5? Sorry, my laptop is. Let me plug my laptop, please. Okay. Okay. Since you can see the example 2.5, they say evaluate the resultant of five forces of magnitude 10 Newton, 12, 16, 20, and 15 acting. So one of these, if you look at that diagram, 10 Newton is missing. 10 Newton is missing. So if you have your pen there, you correct it. There's a typographical error there. So if you look at the how the problem is solved, that 10, you have this in the tabular form: force, inclination to the horizontal components, vertical components. So that angle, that 10 Newton has no angle. There is the one that is directly on the x-axis. That is where you have 10 Newton, and the angle is 0. 12 is inclined at an angle of 50, 20 angle of 40, 16 angle of 90, 15 angle of 60. So if you look at this, on the horizontal components, that will be 10 cos 0. For 12, it will be 12 cos 50. And if you use your calculator, you get the value. You know, cos 0 is 1, so 1 times 10 will still be 10 Newton. So 20 cos this. Then on the vertical axis, you have 10 sine. And sine 0 is 0 multiplied by 10, you have 0 Newton. You have 12 sine 50, you have 20 sine 40, you have minus, look at 16 is on the negative y, and that's the reason why you have minus 16 sine 90. Then 15 is also on the negative y, and that's the reason why you have minus 15 sine 60. So if you sum the total component, you have 9.89 Newton, and then the vertical component you have minus 6.95 Newton, as you can see. So you can now find the total F, the resultant force, which will be the square root of F of x squared plus F of y squared, and it will give us 12 Newton. So this is how you can navigate into the resolution of when you have two or more vectors acting at a various angles. So in this case, so there's another thing we call the unit vectors. What is a unit vector? A unit vector is that which has the magnitudes 1 or unity. And how does this unit vectors? You can get these unit vectors on page 27. Page 27, can you see it? Where you have ijk, and normally a vector will always have three components. A vector will always have three components. If vector A, it will have ax, ay, az. If it is vector B, it will have ax, bz, by, and bz. So those components are the represent the space, and that's the reason why if you look at page 27, vector A is equal to axi plus ayj. It could be azk. But what I want you to understand here is, if you may be asked to find the angle between two vectors. Find the angle between two vectors. Can you see? Look at example 2.6. Can you see? Example 2, example 2, 2.6. Example 2.6. Can you see it? Can you see it? Okay, if you can hear me, or if you can see it, okay. This one is say I'm new here. It's like you just joined. So if you just join, just listen. Just listen. So if you're there, we can so for you to find the magnitudes of a vector quantity, you are supposed to magnitudes, for example, vector A, we are looking at 2.9,